Okay, good morning. My name is Derick Leony from University Carlos III of Madrid. I am a PhD student in the telematic engineering group called Gradient. And basically, I'm going to demonstrate shortly about our tool called GLASS, which is actually an acronym for Gradient's Learning Analytics System. And these here are my colleagues who are also working on the project. I'm basically going to start first with the motivation or the description of the problem that we faced and that is pushing us to actually work on this tool. So there we were with a lot of data, actually tracking students, and we got a lot of the events or the actions that the students were doing in a learning activity. And we are in that explorative stage where we want to see what kind of visualizations we can come up with in order to obtain some hidden information that is in that data set. And in order to obtain that, we are facing many problems that it was very interesting also to see in the keynote or in other presentations of this session, that all of us face those initial issues, like, for example, having to process the data or having to filter the data in order to get them to a further step of visualizing that information. So besides that, we also were seeing that although you could have different data sets, at the end, depending on how you structure your data, it will be possible to reuse visualizations that probably were meant to a specific context, but that placed or used with data of a totally different context. You could also get some sort of knowledge or information from that analysis. So the goal of GLASS is actually to serve as that platform in order to give you a basic infrastructure to start generating visualizations without having to worry on much of that initial issues that are faced at the beginning. Another interesting detail is, for example, that there are not two data sets alike. So there are always, even if you are in the same class, in the same group, and you measure something from one lesson to the next one, there are going to be very different details that come up later on. And it's important to have that kind of adaptation to the data as well, and be able to adapt the tool to the data that you are recording or collecting. And that's the main reason why we are doing GLASS. So I'm going to demonstrate GLASS and two visualizations that we have been working on. First, let me explain a bit about the context of the data that I'm going to demonstrate on. This is based on a computer science course, mainly a programming course. So students work a lot with programming tools, a compiler and IDE for developing their programs. And they also work with an LMS, as many institutions. So they have to, well, they don't have to, they are not pushed to use the forum. That depends a lot on the professor. But they are able to use the web forums in order to communicate and have questions and answers. And well, they also use the web browser in order to access to the course website, the resources, and any other external resource that they find on the web. So we are collecting mainly these types of data. And on the other side, the students work in groups. They belong to different sections. They also have different degrees or majors, depending. That depends a lot of every student. So they have their own characteristics that we could also use in the visualizations in order to try to detect those patterns that could be meaningful for even having an early warning system to try to avoid high dropout rates, or also to help them to actually learn better than what we had before with a less level of data collection. So I'm going to play the Brave card here and do a live demo. This is actually based on real data, but it's being anonymized, and you'll see that we cannot see who the actual students are. So I'm going to start with the first visualization that we developed. The main idea was based a lot on Google Analytics, like trying just to see if we could find some pattern in the data that the students were generating. So on the left-hand side of the screen, you can see just the number of actions or events that the students were generating during the whole term, the 4 months that this class lasted. As you can see, the students are like working with some peaks, some kind of pattern there. And it was interesting because you could see that the places where they were, or the time slots that were not working were actually either holidays or the weekends. But also the time slots where they were working the most was actually right before a face-to-face session, since they were asked to read a previous, previously to read some material for each lesson. We could also detect that they were actually doing that at the last moment. And that was something that we were trying to avoid in this case. And you could also see some peaks of activity right before the submission of a final project, or right before a midterm that they were going to have. But besides of these kinds of just accumulative stats, we also wanted to see what they were working on, and that's the right-hand side of the screen. Many of them were working or were just accessing URLs in the browser. And then it's good to see that also, for example, these 2 bars here are related to the programming tools that they are having to use. And this, of course, changes during the course of the class, because at the beginning it's very explorative for them, so they are just checking what kind of information is out there, a lot of work or activity with the web browser, and not so much regarding the programming compiler, for example. But then at the end of the class, when I have to actually work on their final project, and they are supposed to know most of the concepts and the theory that they have been taught, you can see that this changes dramatically, and they don't browse that much. They just have to work a lot on their project, work a lot on their lessons. So it was very interesting to confirm that they had gained some kind of knowledge from web browsing, or from also the classes, of course. And they were putting that into practice with the tools that were provided. And then what I was mentioning before regarding the different characteristics of the data that you can collect, we tried to generate some automatic filters from the data that is stored in the database. Just for example, of course, there are basic filters like who the student is, or the community that the student belongs to. So if you wanted to compare 2 different students, it's fairly straightforward, and there's not much need to check what kind of information or what the structure of your information is in order to have that comparison. And the same applies, for example, if we remove these filters and we apply it now for the community, like try to see what classes as a group are working or are communicating and collaborating the most in the forum, for example. And in those cases have some kind of intervention from the professor or the teacher in order to improve the collaboration, their communication, and try to push forward those characteristics of the class. So that was one side of the development we were doing. And then, of course, we are very probably technological biased. We try to have that connection to the class also, but since it's a programming class, it's also very technology based. And then, so we went back to some teachers and professors from not higher education, but high schools or K-12. And of course, we now get our eyes open and very important feedback, and they are like, okay, this is very good, but at least for my context, I don't see that much of a reward or of benefit from seeing this, because it's kind of hard to understand, or cognitively it has some difficulty to understand deep visualizations. And the nice thing about, for example, GLASS was that then, based on the same data, based on the same filters, now we developed the second visualization, which was meant to be more straightforward, more very simple, just trying to, let's say, categorize and detect the students that were at the top of the activity and at the bottom of the activity. So on the top row here, you will see, of course, there are fake pictures, they are not our students, but you will see the pictures of their students and try to, well, the tool will tell you what students are generating the most of the events overall, and then based on every single type of event or tool that they are using, you could see in what range of activity level they are. So even though there could be students that are generating a lot of events, it could be because they are just working on one specific tool a lot, but they are just leaving, for example, the collaboration on one side, or if you map this to the learning outcomes of your class, for example, this student here is compiling a lot, so the work on the program is being done, but he is not using other tools that we want them also to explore. He's not browsing for new content. He's not working on that self-learning or characteristic of the student. And if he is not using other tools like a memory profiler, then you could approach them and try to improve that area in their learning. And of course, at the bottom, you will have also the students that are not working at all with any tool. They are just working a bit or checking the browser, and that is it. So our idea was to help the professor mainly to have some kind of early warning system in order to approach and have some intervention to the students. And finally, for the last visualization, this is pretty much a prototype. It's not based on the real data that we have there. But now we are actually approaching both sides or both stakeholders. This is meant mainly for the teacher, since the idea is to have an overall view of how the class is doing. But it's also meant to, we are working on a simple version of this set of visualizations in order for the student to know where he is compared to the rest of the class. So, for example, the right-hand side here will be based on exams or tests. So, in this case, the student, if I was the student, I will see that I am doing way under the average, and there could be some self-reflection there that something is missing there from my point of working. And also on the other side, like trying to have some different visualizations on what kind of tools are my peers working on, how much time they are dedicating in each session to every single point of the class, how much time they are dedicating to browsing and looking for new content, how much time they are dedicating to programming, and how many issues they have been having with, in this case, programming, if they are having errors, if they are fixing those errors quickly, or they're having issues. So that's pretty much the idea, to have that point of comparison and self-reflection for the students. So right now, we are working in this kind of visualization and also on the evaluation of the visualization for the students. And basically, that is it for the demo. And thank you very much, and we're happy to answer any questions you have.
I saw you had an overall graph that showed that sometimes students wait to the last minute before a face-to-face activity was going to happen, and you stated that it's something certainly we want to avoid. But was there any correlation or graphical representation looked at to see if what the correlation between their students waiting to the last minute and performance? And was that something that was considered as far as being able to represent that for the educator? Right.
That was one of the approaches, but basically, since here we are based on the visualization side and not on any kind of, let's say, statistical analysis or artificial intelligence, we also have tried with other approaches or other lines of research to find those variables that could correlate with either the final grade or the grade of the project, for example, and haven't found any specific variable that we actually correlate a lot with that. So that will be the answer, I think. But since we are based on the visualization right now, like trying to check the inside of there, and it might not correlate, for example, but it's something that you actually want the students to learn, to have a constant work rate. So still, it will be important, at least in our context, to try to avoid these kinds of behavior.
Hi. I'm impressed by all the things that you can, pull out about the students' activities. And I wonder, I'm sure that there's some correlation between the extent to which the learners are doing the right things at the right times and their learning. But I wonder if there are any analytics, there's any data that you can pull out about their actual conceptions and how they're moving over time, growing or not growing over time as they're doing these activities. I mean, I'm not, for example, using some simulator or whatever that's in there. I don't know exactly what tools they're using. But is there a way to extend this so that you can get more about what their conceptions are? I know you said that, user models are hard.
Yes, thank you for the question. That was actually the idea with GLASS. Like, in that case, we are not collecting their conceptions right now about their learning or even about the tool itself. So it will have to have a data set that includes that information first, and then be able to have some either visualization of that information or try to correlate it with their performance in the class. So that depends a lot on the data that we have.
So is there any kind of data besides grades that's easy to get that would have something to do with their performance?
That's a tough question, actually, because that's what we're trying to find. Besides the grades, we're only collecting, for example, self-assessment results, and they are not included into their final grade, but we have found some kind of correlation, but it's also a test at the end, so we are not completely sure that we could use that outside of the grade. Mm-hmm.
If I may, if you have a self-assessment on a specific topic, on a specific concept, then you can, I guess. You can then know, so answer this kind of question.
Yes, you're right. And the issue with the self-assessment is that in that case, in order for not being included in the grade, is also optional. So we don't have we have some kind of engagement, and that's what actually the last visualization is based on regarding the engagement here. Those are based on self-assessments on specific concepts embedded in the content. So we, more than just analyzing the performance of the student, we relate it to the engagement, because it depends a lot of if they want actually to self-assess themselves. That is what we are trying to correlate it with, more than the performance at the end. Mm-hmm.
Thank you. I think this is the end of the session. And thank you, Derick.
Thank you.